Hello, everybody, and welcome to this WATS live webinar. My name is Ola Lundreppe, and I am Customer Success Manager for the WATS team. I will be hosting this webinar where we will be addressing MES systems and how WATS can be used to implement mechanisms that can help you maintain control of your production, even without a manufacturing execution system. Today, our CEO and product manager, Tom Lomsdalen, is sitting in as a panelist and ready to help with any questions that might come up. So if you have questions during this session, please use the chat window to post these, and we will try to answer them to our best ability, either live in this session or by email afterwards. I expect this session to be lasting anything from 40 minutes to an hour, depending on the amount of questions that might come up. I'll begin with presenting some of the challenges with implementing a traditional MES system and the benefits and possibilities that WATS offers before I will move over to the WATS application to showcase some of the functionality. So manufacturing execution systems, what are they and what are the scopes of these systems? And in this definition, tracking and documenting the transformation of raw materials to finished goods is obviously a scope that is very large. And as such a system, when set up successfully, can be a powerful tool to help you control and improve your production quality and efficiency. It typically involves management of production definitions, different resources, both human as well as management of hardware and equipment. It includes scheduling, forced routing, and a lot more. And along with all its benefits, implementing such a solution also comes with some risks and challenges. And some of these challenges or drawbacks might be that it is a huge effort to implement such a system. And hence it also takes a lot of time and it's a costly implementation. Also, these systems tend to be somehow rigid and you need to consider how well it copes with changes in your products and in your production facilities, new suppliers or CMs. What about company consolidations and strategy changes? Our experience also tend to show that compared to WATS, these systems are often inferior when it comes to test data analysis. And because of this, because of the implementation issues, which are increased with a large enterprise over multiple sites, we claim that this might be a better fit for a CM or a single site operation. So over to WATS and what WATS can do for you in this context. WATS, first of all, is not and has no ambition to be a manufacturing execution system, but still there are quite a few features that, if configured correctly, can assist you in controlling your production performance. In addition, WATS is easily implemented. It enables you to get started quickly with minimal implementation costs. And the real-time data collection in WATS allows you to monitor your production and enables early detection and analysis of unwanted behaviors. The WATS features that I will be covering today are software distribution, a system to ease the distribution, installation, and execution of test software on your test equipment. Asset management, which helps you keep track of all your test assets in terms of number of runs, maintenance schedules, and calibration. We have serial number and MAC address handling, which enables you to control and distribute both serial numbers and MAC addresses. We're going to briefly discuss the dashboards and the visual reports. We're going to have a look at the KPI targets. And we're going to investigate the alarms and notification module. We're going to look briefly at the ability to use manual inspections and to log repair operations. And finally, we are going to take a look at the unit verification and unit grading. So first of all, I want to start with looking into some of the details of the software distribution module. And the software distribution module is meant to ease the management and distribution of your test software from the WATS cloud to the different test stations. It lets you manage your test software in the WATS cloud. Also, it has automatic revision handling. It supports any file type. So even though this is originally intended to distribute test sequences and test software to the stations, there's nothing stopping you from distributing any file that you might need to distribute and install. You can distribute the files to any site or any station available. This helps you avoid human errors and wrong software versions, as well as wrong firmware versions. This includes both the distribution part, the installation part, and not least the execution part, where you can eliminate the number of human operations. It's supported and ready to run out of the box with the test stand add-on. It's also available out of the box with the WATS client using the package manager. And you can use and access the software, install and run it using the watsclient.net API. Next up, I want to look at the asset manager. And the asset manager has been available as preview for some time and will be released in our upcoming release in a few weeks. And this module also utilizes the live connection that WATS has to our test equipment. And it does so to manage and warn about maintenance and calibration status. So it keeps track of all the test stations and all the child assets, all the assets connected to the test stations. It can log any hardware or assets connected to the station. It can track the number of test runs that each asset has performed. You can assign individual maintenance and calibration intervals for each type of sub-asset. And you can also assign warning and alarm thresholds. It lets you alert the operator before maintenance or calibration is due, and hence it avoids unplanned halts in your production. The next feature we will be inspecting is the serial number handler. And the serial number handler provides the functionality to create series of MAC addresses or other serial number formats on the server. The WATS client or API can be used to reserve and take serial numbers, eliminating the risk of duplicates and ensuring traceability. So out of the box, WATS comes with two types of serial numbers. One is MAC addresses and the other one is running serial numbers. These two types can be viewed as examples because on your request, we can create custom serial number formats. That means we can create complex formats consisting of both letters and numeric symbols, and they can also have logic such as parts of the date or production site can be included in the serial number. Once they are created, you can define ranges or import ranges to the WATS server. It ensures that unique serials are distributed to your units. It supports offline mode by letting the client reserve batches of serial numbers so that it can work offline until the batch is used. And it is available both from the add-ons and from the WATS client and the API. Next up, I want to talk briefly about dashboards and reports. We're not going to spend much time on this since this is a complex subject with that we don't have the time to go into in detail. But At the core of WATS are the reports, and these, along with the dashboards, enable you to do analysis of top-level KPIs, which enables early detection of unwanted scenarios, as well as it enables detailed analysis of individual tests or measurements or repairs. WATS offers a range of visual reports to monitor your production KPIs. And our advice is to use the top-level reports to detect poor performance. Use the drill-down functionality to move into more detailed reports, such as the test step yield and analysis or the process capability analysis. And using the dashboards, you also have the ability to visualize and monitor your KPIs. Next up, KPI targets. When viewing large grids of data, noticing the small details that stands out might be a challenge. And the KPI targets are supposed to help you out with that. All WATS reports display the KPIs in traffic light colors based on the KPI targets. So if it's above warning level, it will display in green metrics. And if it's between alarm and warning, it will display in orange. Or if it's below the alarm level, it will display in red colors. You have the ability to assign individual warning and alarm targets for different products and revisions, and also test operations. And this is useful since you probably have some processes that performs steadily with a very high yield, and other processes that might fluctuate or have a lower yield. So you can assign targets that are specified for each product. The color codes make poor performance easier to detect. Next up, alarms and notifications. And the alarms and notifications module allows you to automate parts of your monitoring. And it does so by defining scenarios that you want WATS to alarm you about. It contains a wide range of conditions. You can monitor individual measurements. You can also monitor yield levels and yield trends. But this feature comes with a warning to be cautious. Be cautious not to raise too many false alarms. And also, alarms and notification, to use this successfully, you need to spend some time and some effort in tuning your alarms. Next up, I will briefly mention manual inspections. Not all production tasks can be automated, and with manual inspections, WATS offers a highly configurable tool to create and execute manual tests and inspection sequences that are logged directly into the WATS cloud. Here you can design and distribute and run your manual inspections directly from the server. By scanning a unit, you will automatically be shown the available tests for that part number. Every manual inspection automatically creates barcodes, and they are generated to minimize the keyboard input, letting you scan barcodes to pass and skip tests. It supports advanced configuration and display of PDF instructions side by side with actual test sequence. And it also lets you analyze and visualize your manual inspection data the same way that your automated test data is displayed. Same thing goes for repair operations. Built-in functionality to configure and execute and log repair operations. You can log the operations directly in the WATS operator interface. It enables you to upload boom lists and vendor lists for consistent user input. You can define custom repair categories and failure codes. You can replace and repair subunits. And finally, you can also use the repair analysis to find the root cause While your test data analysis will provide you with the symptoms of your production issues, adding repair analysis will enable you to find the actual root cause of your failures. The next topic I will be looking into are what we call the unit verification rules. And these rules let you specify which test operations should be run for a certain product and in which order. It lets you define a list of the test operations and the order of execution. You can scan a unit in the operator interface to inspect its grading. It enables reports such as the total process yield, which shows you statistics regarding finalized units. And finally, in addition to the built-in reports and features to verify your products, our API will allow you to query any historical information about a unit. And you can do custom verification that you see fit. You can do this both when the unit is in production, to do, for instance, check if a previous test has been completed, or you can do it after the unit is finalized to track the unit's production history. Be cautious not to implement such verification in a way that will halt your production if the API for some reason does not respond. For instance, if it's offline. And along with unit verification rules, we also have what we call unit grading. And unit grading allows you to scan a unit and verify its status and its grading. And the status codes are either OK, which means all tests are passed. It can be warning, which means all tests are passed, but not in the correct order. And we have a not OK status, which means that one or more of the tests did not pass. In addition, we have the grades, which are A. Everything is in order. All the operations have been run and passed in the correct order. The next one, B, means that all the processes have passed their tests, but the execution order is incorrect. Grade C means that all processes have passed their last test, but one or more earlier runs failed. It means it's been retested. And grade D means that everything has passed, but the unit has been repaired. So this can be accessed from the operator interface. So from here, we're going to move over to the WATS application to look at where and how these features are configured. And the first feature we will look at is the software distribution and the asset management. So to configure the software distribution module, you need to go into the control panel. This can be reached from the start page or from the main menu. And in the control panel, you need to access the process and production menu and the production manager. The production manager contains both the software packages and also the manual inspection sequences. We will not be going into the manual inspection sequence design in this session, but you can be aware that these are configured in much the same way. The difference is that the software package results in a list of files that are distributed to the server, while the manual inspection sequence results in a test sequence that can be executed from the operator interface. Apart from that, they both contain revision handling and more or less the same features to identify it. So in this case, I will be looking at, sorry about that. In this case, I will be looking at the software that is contained in this folder and for the product with the part number 24.11.19.825. And if I expand this folder, you can see that there are 4 software packages in this folder. These green icons lets you know that these are released. And once a package is released, it cannot be edited. I can use this show and hide icon to include or exclude different data. So if I include the revoked, I will also see all the packages that the previous versions that have been revoked. Let's remove that one again. When I open one of these software packages, let's look at the installation test, for instance. I'll be able to see 3 tabs to the right. The first one is the package overview, which lets me know the name of the package, when it was created, its version, and some settings. Next up is the tag section, and this lets me identify the package if I need that identification outside the actual package name. So I could go ahead and add new tags and link this this package to, for instance, part number, revision, or any tag that I would like to add. Both tags and package name can be used in identifying the software from the client. In addition to the tags, you also have the list of files. And before I go into the details of this list, I will create a copy of this software package that I want to release as the version number 3. So I select this one and click copy, and it will automatically create a copy that is in draft. You can see that from the blue icon. Now that this is in draft, I can edit it. So let's go back into the file folder and look at what's in here. First of all, there's a folder for documentation where you have 2 different documents, and you can see that these different files have attributes assigned to them. This one has no attributes. This one has the attribute execute always. And what this means is that execute once will open this file on the first installation of the package. If I leave it at execute always, it will open this file every time the package is run. So I'll leave that as always, which will mean that the instructions will pop up every time the sequence is started. It also contains some sequence files. In this case, this is a test stand sequence, and it has some XML files, and it has a limits file that is a CSV file that contains some of the test limits for these tests. I can actually go ahead and edit this CSV file directly in the user interface using this file editor. So I could go in here and change the limits without opening the actual sequence. So in this case, let's change this low limit from 1.5 to 2.0. Okay, and save and confirm. We also have a firmware folder that also holds a CSV. You can look at that as well, showing the firmware version. You can also change that directly in here. And we have a folder with LabVIEW test VIs. None of these need any attributes assigned to them since they're loaded by the top level file, which is the sequence file here. And you can see that the attribute here is set to top level file, which assigns this file as the execution point for this software package. Once that I've done all the changes that I want, I can release this package. And the releasing is done in different stages. So you can first move it to pending, which is an intermediate step. And in this step, I can no longer change the package, but I can move it back to draft if I want. And from here, I can release it. And you can use the draft mode to do testing on this before you release it to production. You can now see that the installation test in release has version number 2. The one in pending has version number 3. So once I click release, this will be moved to released, and the previous package has been revoked. To demonstrate how this works, I will now open up TestStan and execute the test. And in this case, I want to test this part number. The revision is 3.2, and I want the installation tests. Clicking OK here now should make the add-on query the WATS server for a matching package, and in this case it will use the package name. So by default it will look for a package called part number underscore revision underscore test operation. So if this works out okay, it should download the package, and oops, okay, there was something wrong that made this not execute, and I'm not going to spend any time in investigating what I did wrong here, but in essence, this is how it works. So once this this package is picked up, it will download and run. Okay, so from the software distribution module, I will move over to look at the asset management. If there are any questions regarding the software distribution, I guess I could stop briefly to look at that. Just a moment. No, there are nothing, so I'll just keep on. So the assets can be found under this menu item, and it consists of two menus, the asset types and the asset manager. First, I will open up the asset types, and this contains a list of all my predefined types of assets. And for each asset type, I can create individual limits according to the count, the running count, as well as the calibration intervals, the maintenance intervals, and I can also define the warnings and thresholds. So if you look at this one called default, it is set up to have a running count limit of 1,000. That meaning that when we reach 90% of this running count limit, a warning will be raised. And once this warning is raised, or the alarm is raised, or the count limit is exceeded, you are enabled to reset this counter. And you can reset it until the total count reaches the total count limit. So in this case, I could reset and restart this counter 10 times until it would reach the total count limit and the end of its lifetime. In addition, it's set to have a calibration interval of 365 days, meaning when I reach 90% of 365 days, a warning will be raised about calibration. At 95, it will raise the alarm. Same thing goes for maintenance interval, and you can, of course, configure these two thresholds and warnings. Going into the asset manager, please be aware that this is in preview, and the release that is scheduled a few weeks ahead will be somewhat different. So I won't go into the details here, but the general idea is that this list will contain all the assets that you have defined. The assets are identified by a serial number, and either by using the API or by using the uploaded UT reports, you can add the counter limits for each of these different assets. The assets can be stored in multiple levels, so you can have child assets to the test station, which in terms has its own child assets. And depending on the type, they will follow different maintenance intervals. So by looking at one of these instruments or one of the assets, I can look at the actual counters and limits, and you can see the running count and the total count and the calibration and maintenance status. And from here, you can also both increase and reset these. And as mentioned, you can increase these counters either by using the API when the test is performed, or by posting the serial number of the asset on the UT report, the counter will be increased automatically. So that is more or less what I was going to show in terms of asset management. I can see there is still no questions, so I will move ahead. And the next topic is the serial number handler. The serial number handler can be found in the process and production menu. And on the server, it contains a list of all the batches or all the ranges of serial numbers that are defined. So as I mentioned, this comes out of the box with MAC address and running serial number. A simple running serial number starting from 0 and incrementing with 1 for every step. But you can, by contacting our support, have your own custom serial number formats defined. And once they are, you can generate a series on the server or import from an XML file. And using the WATS client, you can also configure how the client should handle its serial number reservation in terms of choosing the batch sizes, when it should fetch new batches, if it's supposed to be in sequence, and from what serial it should start, and so on. You can also use both the test and add-on or our APIs to reserve batches and take serial numbers, and also to free the reserved and delete the free serial numbers. And inspecting one of these ranges, I can also see which serials are free, which are reserved and taken, and when they're generated, reserved, UTC for when they're taken, and also refers to the serial number and part number that has this serial assigned to it. So this helps you avoid duplicate serial numbers. It helps you stay in control of which serial numbers have been assigned to which units. Next up, I'm going to have a look at the KPI targets. And as I mentioned in the presentation, the KPI targets lets you define warning and alarm levels for individual yield types, product groups, part numbers, revisions, and test operations. And when viewing the KPIs through the WATS application, WATS will always choose to use the more specific rule over the general one. So let's go into the process and production again and look at the KPI targets interface. So what this shows is a list of all the targets that are defined. And we can start with the most general one, which is the default one, which comes out of the box with WATS, and it's this one called any. And what this does is that it defines that for any yield type and any test operation, for any product group, no matter what the part number and revision is, these are the rules that apply. So the warning is at 95%, and the alarm is at 90% when it comes to yield. So if no other specific rule is defined, this is what will apply. And this is what we will see when you get what's out of the box. Every figure, every percentage that is above 95% will be green. Everything between 95 and 90 will be orange, and everything below 90 will be red. So if I want to specify for a given product other warning and alarm levels, I can choose to do that, and I can specify this for any yield type. I can do it for the test yield, for the first, second, third, or last pass. So in this case, I want to create a specific one for first pass yield. I will let it apply for all the test operations, and I will not specify a product group. So here I can actually, if I choose one product group, this will apply for all the products that are available in this product group. Instead, I will introduce a part number filter, and my part number is 24, and I can actually use wildcards here. So I could say 24 like this, and this will apply for all part number starting with 24, but I want to be more specific. So I'll type in the entire number. And I'll leave the revision open to let the rule apply for all revisions of this product. I want to set the warning at 97 and the alarm at 95%. So once this is done, if I inspect a chart or a grid that contains yield for this part number, it will always use this more specific rule. But if it contains different yield for different aggregated yield for different part numbers, and it's not this one in particular, then it will fall back to the next more general rule and apply that one. And in the end, if nothing else fits, it will use the default any rule at 95 or 90. And you can of course also change the warning and alarm levels for the default rule, but you can't delete it. Okay, that is it for the KPI targets. Next up, I will be looking at the alarms and notification section. It's in the same menu, process and production. And what this does is that it lets you automate some of the monitoring by raising alarms when certain scenarios occur in your production. Alarms can be set to monitor specific UT report data, yield metrics, as well as individual measurements and CPK values. And this can be a powerful tool when used thoughtfully, but as with any automated statistical monitoring, its efficiency is greatly influenced by your ability to avoid raising a lot of false alarms. So to demonstrate, I will create a custom yield alarm. And to do that, I will create a new rule and I will name it and once you create one of these rules, you need to select one out of 3 types. So you have the UT reports, alarms based on the header data from UT reports. I can create alarms based on yield and volume or on the measurements. So in this case, I will select yield and volume. And the first thing I can then select is the period grouping and number of periods I want to include in my rule. And what is important to remember when you create alarms like this, both to avoid raising too many false alarms and also to make the alarm strict enough that it will be raised when you want it to be. You need to keep in mind the volume of your production. So if you go ahead and make alarms that are based on 1 hour and you have a low volume of production with maybe just 1 unit produced per hour, this will of course make the yield fluctuate a lot from hour to hour. You could risk that you only have 1 test in that hour and that failed, which will give you a yield of 0, or you could risk having 1 test that passes, which will give a yield of 100%. So you need to be aware of the product you're looking at and the volume that is produced for this product. So in this case, I will look at days, and I will look at 2 days at a time. And for this, the next step is to apply the conditions, and the conditions are when should this alarm be raised? So clicking this will give me a list of different conditions. And we are going to look at the first pass yield. But to ensure that this is not triggered by on a very, very low volume, I will use the unit volume and set that it should be greater than 5 units. I won't raise this alarm if there's just 1 or 2 or 3 or 4 units produced during a 2-day period. And you can, of course, configure this to match your needs. And I can add more conditions. I can also set that at the first pass yield, it should be, I want to be alarmed when the first pass yield drops below 90%. And I also want to add a condition no, let's leave it at that. Remove this one. And next, when the conditions are set, I can set filters. And filters let me narrow down what data should be considered, because so far we're only looking at yield. We're not specifying which products or station or anything. So in this case, I want to look at the part numbers, and I want the part number to be 24, and I'll use the wildcard to include all the products that starts with 24. And I can keep adding more conditions. I could also use OR conditions. And I want the revision or batch number or station name to be some specific property. In this case, I'll leave it at just the part number. And the last thing you need to do to create one of these rules is to decide what action should be taken when this occurs. So I can choose from email to recipients or email to members of a role. And in this case, I will email myself. And finally, I'll save the rule, and it will show up in this list. In addition to the list of rules, I also have alarms log. So here I can see historically which alarms have been raised and when, in addition to the emails that will be posted to my email once these alarms are triggered. So that was what I intended to show when it comes to alarms and notifications. The next up is the unit verification rules. And the unit verification rules, to explain them, I'll need to look into multiple interfaces. The first one I want to inspect is the process list. Because looking at the process list, which is a complete list of all your test operations, your work in progress operations, and your repair operations, you will find that they have a name which is used for identification, and it also has a code that is used for identification. In addition, it has a process index. And sorting this, you'll see that the process indexes can range from 0 and up to as large a number as you want. And essentially, this process index is what determines the order of execution. So if I was to create a unit verification rule that implies that the product should run through calibration, final function, you can see that since calibration has a lower process index than final function test, it implies that this one should be run first and this one should be run last. So the final test is always the test with the highest process index. In cases where they are the same, for instance, here you have a lot of tests that are set to 0, the order of execution between those tests will not apply. So you could if you introduce both this RF test and programming, they can be executed in any order. If I should change this index to be higher than the other, that will enforce the order of execution. So once we know this, we can go into the unit verification rules, and you will be presented with a list of all the existing rules. Here you can see that same way as the KPI targets, you can have general rules and more specific rules. And the same thing applies here, that WATS will always execute or use the rule that is most specific to the data you are looking at. So to implement a specific rule for our product in this list, I will click New Rule, and I can edit the rule directly in the grid. First of all, I can assign it to apply for an entire product group. So I could say that any product in the common product group should have this rule. In this case, I will leave product groups empty, and I will use the part number to identify the rule. So I'll type in the part number. And I can also choose to type in a revision, but I'll leave this open. And I can choose what test operations are supposed to be run for this product. And now I want this product to run a burn-in test, and I want it to run the final function tests. I want it to include installation tests, and I want to include a pre-burn-in test. Once this is defined, this will let me inspect the grading of any product that is tested in the system. So let me find a serial number, and I can show you how this works. First of all, I will go into reporting. And here we can find one of the reports that are utilizing this functionality is the total process yield report, which shows a product as finalized when it has completed the last of the processes in the unit verification rules. So looking at this product, I can now see that according to my setup, my rule that I just set up, in March, I had 15 units started, none were finalized. And so far in April, I have started 32 units and 9 of them are finalized. So 9 of these units have passed their tests and passed the final test and hence show up in this list. Moving over to the operator interface, I can choose to scan a serial number for this part, which will automatically bring up the serial number history. And using this button, I can go to the unit verification. And once I go to the unit verification, I will get the grade and the status of this product. And as you can see, this one gets a grade C because all processes have been passed, but one or more earlier runs failed. So here we have retesting, and you can see that the final function test is run 3 times and it has failed once. So we have 2 retests here. That concludes the unit verification part. And moving ahead, I want to say something about the reports and dashboards as well. Let me go into the dashboards, and I will not talk much about dashboards and reports, but from viewing different WATS instances around in our customers' locations, I can see a few things that could be done better. And one of them is how the dashboards are used. Let's open a station map just to look at this. What is important to know to utilize the dashboards in a good way is that the dashboard is very tightly linked to the product groups and level features. And this quick filter in the top right-hand corner of the dashboard is what's controlling both the time that is displayed in the dashboard and also the data through. So here I can go ahead and say that I just want to look at the common products, the products that are in the common group. So once I click this, the dashboard will change to only apply for these products. And this greatly reduces the number of dashboards needed. The same thing goes for organizational levels. I can go ahead and say, I just want to see the data from Brazil. So when using these dashboards, when possible, I advise that you create and maintain the product groups and the levels, and try to use this dashboard filter in any case where it's possible. In some cases, that is not possible. In some cases, you will have to use static filters inside your widgets, making some of these features not function. And when you do that, please make sure to display the widget title, which is this line over here, and use the widget title to describe what is being displayed in the widget. Unless you do that, this is going to be very confusing. If I change from 30 to 7 days and one of the widgets in the dashboards are statically set to show 1 week or 3 weeks. That is what I was going to say about the dashboards. And in addition, I have one more advice for the dashboards, and that is, don't try to cover your production monitoring with dashboards alone. Dashboards are really useful to displaying data, but the core top-level analysis of your production is actually best handled using the reports. I would advise to spend more time using yield reports, the dynamic yield reports, and the periodic yield reports to inspect your data from a day-to-day perspective. And also, I would like to stress that you should try to make a habit of using the drill down functionality. So what we want you to do is to use the top-level reports to actually discover these underperforming data sets and use the drill down to move into the detailed reports. There's of course nothing wrong with starting in a detailed report in the case where you know exactly what data you are looking for, but making this a habit will increase the risk of developing a biased attitude to what data needs inspection. So you will start to inspect the same sets of data over and over again, which in turn might leave other underperforming processes undetected. So the intended use is to use the yield report, periodic yield report, to identify data sets that underperform and use the drill down to move into the test step yield analysis or the process capability analysis or whatever report you will need. That is more powerful than just looking at designed dashboards. Okay, so that concludes what I was going to demonstrate in this session. If there are no questions or no comments from Tom, I think I will finish there. I will be holding a new release webinar once the next release is out. So please stay tuned for that one, where we'll be going in more detail into the new features that was mentioned in this session. So thank you for watching, and have a nice day.